Welcome to Intelligent Membranes CPD Advanced Technology for Achieving Airtightness. In this CPD, we explore the benefits of liquid-applied airtight membranes and how they can be used by main developers, house builders and contractors to achieve better airtightness performance and thus providing superior comfort for occupants and users. We will be exploring current solutions and technologies for achieving airtightness, as well as presenting a balanced overview of their pros and cons. Throughout this presentation, we will be making reference to our liquid-applied airtight vapor control coating and how it's revolutionizing the way professionals within construction deliver safe, effective and sustainable outcomes. We hope you come away with a fresh perspective and an improved understanding of liquid-applied airtight membranes. We'll begin by outlining the key learning aims, objectives and success criteria. Our learning aims and outcomes are as follows: to learn more about liquid-applied airtight vapor control membranes and their benefits, and to understand the airtightness technologies available. By the end of the session, we hope you will understand the different solutions that are available for achieving airtightness, gain more understanding of the latest regulations around airtightness, and gain more clarity on what makes a liquid-applied membrane effective. We'll address these learning objectives at the end of the session. We recommend making a note of these objectives to use as reference points throughout. Before we begin, we'll provide a brief company overview to ensure you know who we, Intelligent Membranes, are and what we're about. Intelligent Membranes manufacture and supply high-performance liquid-applied construction materials. With 22 years' experience, we have been creating innovative liquid technology for the construction industry for more than 2 decades. You will see our products in many buildings across the UK, with hundreds of main developers, house builders and contractors benefiting from our innovative solutions. We champion Passivhaus standards and strongly believe that this methodology should be accessible to all buildings. Achieving airtight buildings and high levels of insulation is what we feel passionately about. In doing so, we are helping to achieve more sustainable outcomes for all building projects. Climate change is undoubtedly the greatest challenge of our time. Science is now showing with alarming clarity how quickly we are running out of time to avoid catastrophic and irreversible changes to the world around us. The 2008 Climate Change Act made Britain the first country in the world to set legally binding carbon targets, aiming to cut UK emissions by 34% by 2020 and at least 80% by 2050 through investment in energy efficiency and clean energy technologies such as renewables, nuclear and carbon capture and storage. However, what is expected and what is achievable are two different things. Quite often, changes in building design and improvements in fabric all have significant cost implications. Here at Intelligent Membranes, we believe that superior, effective airtightness should be accessible for all buildings. If we seek the definition of approved documentation, then Approved Document F, ventilation, defines airtightness as a general descriptive term for the resistance of the building envelope to infiltration with ventilators closed. The greater the airtightness at a given pressure difference across the envelope, the lower the infiltration. Airtightness is the fundamental building property that impacts infiltration and exfiltration, the uncontrolled inward and outward leakage of outdoor air through cracks, interstices, or other unintentional openings of a building caused by pressure effects of the wind and/or stack effect. As you can see from the image, air leakage can occur in multiple places throughout the average household. For example, junctions between walls and other walls or floors, junctions between window frames and walls, electrical equipment, and access doors and other wall penetrations. The orange arrows represent air leaking out of the house, whilst the blue and purple arrows demonstrate air leaking into the house. An airtight building means an energy-efficient building. Because the mixing of indoor and outdoor air is limited, users will benefit from reduced energy bills from heating and cooling. Energy Star, a government-backed program which provides certification to buildings and consumer products which meet certain standards of energy efficiency, has conducted research on commercial buildings and found that a property can waste as much as 30% of their energy usage due to airtight issues. By making small upgrades, the energy efficiency of a building can increase by 10%. Having an airtight building has many benefits. These include lower running costs through reduced heat loss, improved comfort, improvement in energy efficiency within the heat recovery ventilation systems, improvement within the energy efficiency of the entire building, reduction in moisture infiltration levels. The Building Regulations Approved Document Part L1A 2010 now specifies that any dwellings are built airtight. In England and Wales, airtightness testing has been mandatory for virtually all new buildings since 2006. The building regulations require that 50% of each home type in a development must undergo airtightness testing. The definition of home types was expanded in the 2010 revision and includes differences in position, for example, terrace versus end terrace or top floor versus ground floor flats. In addition, the rules require that half of the plots that are tested must be within the first 25% of completed properties. The regulation is focused upon conservation of fuel and power usage. Part L1A states that any new dwellings are tested for airtightness in accordance with Table 1 as shown on this slide. Airtightness testing is carried out by using a method known as blower door test in accordance with BS-EN 13829. The measurement is taken by blowing air into the house via a particular door that is mounted in the main entrance. By the use of thermographic equipment, leakage paths can be identified. The new Part L1A requires an air tightness of maximum 10 cubic meters per hour per square meter air loss at a pressure of 50 pascals. Standard good practice for airtightness testing in the UK is a maximum of 7 cubic meters per hour per cubic. Standard good practice for airtightness testing in the UK is a maximum of 7 cubic meters per hour per square meter, and best practice is 3 cubic meters per hour per square meter of air loss. The latest documentation to be released by the government is the Future Homes Standard, changes to Part L and Part F of the building regulations for new dwellings. Included in this is a chapter on airtightness. It touches on how there may be a change to the blower door test to a pulse test, making it even harder for new dwellings to pass. It's clear that compliance is becoming more and more difficult, and with good reason too. Before we move on to the solutions available for achieving airtightness, we explore the UK standards for ventilation. In April 2002, the UK government introduced legislation to enforce standards of building airtightness. This was intended to lower running costs, verify the standards of materials, components and workmanship, prevent uncomfortable drafts, and avoid condensation problems. This is achieved by air permeability testing, air tightness, air infiltration, or blower door testing, which measures the air leakage rate per hour per square meter of building envelope area at a test reference pressure differential across the building envelope of 50 Pascal, 50 newtons per square meter. Therefore, in a domestic property, it is important to ensure that ventilation is circulated throughout the whole building. Extract ventilation must be used within an area of increased humidity or pollution, for example, an extractor fan over an oven, and purge ventilation must be possible, which is dependent on the area within the premises, but could simply refer to the ability to open a window to air a room out. In non-domestic premises, including places of work, priorities include the continuous circulation of clean air. For example, with an air conditioning system, which can be straightforwardly accessed and refurbished when needed, and minimizing the potential risk of any airborne illnesses or allergens. All professionals involved in the design or build has a duty of care and can play a role in achieving better airtightness performance. Everyone needs to know about airtightness. The design team, site management, trades and site labourers must be made aware of the importance of airtightness and their roles in achieving an airtight dwelling. The following slides will focus on what solutions are available and currently being used to achieve airtightness. Airtightness. What are your options? Traditional methods of airtightness include the use of silicone, paper and adhesive tapes. These are all readily available in the market and commonly used throughout the construction industry in new dwellings. Despite their respective popularity, these more traditional methods are not without their faults. We will now aim to address the pros and cons of these methods. The popularity of silicone, paper and tape applications could be due to a number of factors, as highlighted in this table. For instance, paper and tape have no drying time. However, it's important to note that whilst this may appear to speed up the application process, all methods will require multiple applications in order for it to produce positive results. This may turn out to be a lot more time-consuming in the long run and more labour-intensive. In order for professionals like you to help deliver on the UK's Sustainable Development Goals for dwellings, we believe that a solution driven by ease of application, safety and sustainability is what is needed in the construction industry today. Liquid applied membranes. More businesses, organisations and users are turning to liquid-applied airtight vapour control membranes. We refer to them as next generation due to their high-performance properties and significant green credentials, helping professionals achieve safer, sustainable outcomes for their clients. We will now outline the scientific characteristics of liquid-applied membranes and why this revolutionary airtightness solution is gaining more and more popularity within the construction industry. A lesson in science. How do liquid-applied membranes work? A liquid-applied membrane, LAM, is a fully bonded liquid-based coating. Due to its many benefits, which we will outline shortly, you will find this coating being successfully used for a range of construction applications. The coating cures to form a rubber-like elastomeric membrane and may be applied over many substrates, including blockwork, timber, MGO board, foam block, woodcrete, spray-applied foams and concrete. We will now explore external and internal use of liquid-applied membranes. This picture demonstrates the use of a liquid-applied membrane on the external facade of a building. As it's a vapour control, this liquid-applied membrane should only be applied to the warm side of the insulation. If applied to the facade, the user should insulate over it, for example, in a retrospect term. We will explore this further in our case study later on in the session. It can be applied in any direction by an airless spray device, brush or roller, and can be used on masonry, brick, timber frame, woodcrete and foam block. Please note that when using any application device, appropriate measures should be taken. This includes the correct use of PPE, including gloves, goggles and overalls, and respiratory protective equipment, RPE. When specifying a liquid-applied membrane, look out for VOC-free. Products that are VOC-free don't contain any volatile organic compounds in them. Nonetheless, protective measures should always be taken to ensure safety to the user. Internal use of liquid applied membranes. Air leakage paths, which are commonly found in dwellings, can be easily controlled through the internal use of a liquid applied membrane, LAM. This particular membrane can be applied in any direction by an airless spray device, brush or roller. It can be applied onto blockwork, timber frame, SIPs, joints, ceilings, door and window joists, floor and wall connections, pipe penetrations and more. Please note, the techniques of minimizing joints or using inherently impermeable materials like concrete or sheets panels such as ply, OSB or CLT are fundamental to an approach to designing and specifying for air tightness. As previously mentioned, always ensure you use appropriate PPE when using any liquid applied membrane product. Why liquid applied membranes? This advanced technology is revolutionizing the way builders achieve airtightness, and this table demonstrates some of the many benefits that a liquid applied membrane will have within your application. The client, end user, will save time and money whilst having the best performing product the market has to offer. It doesn't hide the problem. It becomes part of the fabric itself. Ease of use. Easy application in the most challenging of locations and objects. It doesn't deteriorate over time, meaning that airtightness will maintain its longevity. Super fast application with either a brush or spray. Extremely durable. After it dries, it turns into a hardened polymer, which is a lifetime guarantee of airtightness. No continuously searching and repairing for paper rips and tears. Some liquid-applied membranes move with the building settlement and substrate movement and do not shrink or deteriorate over time, offering a full, complete airtight seal for as long as the building stands. It's also Passivhaus certified. Please note, however, that you should always seek fire rating certification when specifying a liquid-applied membrane. As defined in Approved Document B, it's crucial that any component of an external or internal wall construction should address the issue of combustibility. At Intelligent Membranes, our liquid-applied membrane has been tested under the Euro classification system for fire safety and has been given a rating of Class C S1 D0. Please be aware that a Class A2 S1 D0 or better rating is required to be met for external wall materials of relevant buildings above 18 meters in height. Liquid-applied membranes. Technical benefits. From a technical perspective, we'd like to take this opportunity to highlight some of the main technical benefits that our liquid-applied membrane has to offer. As previously stated, it is Passivhaus certified, which is said to be one of the most carbon-friendly construction methodologies in the world today. Very low air leakage rates are required by the Passivhaus standard and must be demonstrated for each certified building by means of a blower door air tightness test. The air change rate must be less than or equal to 0.6 air changes per hour under test conditions. It is also BBA certified. Our liquid-applied membrane is a fully BBA-certified liquid airtight vapor control layer. It is a radon barrier. Inside a building, people inhale tiny particles of radon, which then irradiate the lining of the lungs. Radon can cause lung cancer, and it poses a particular threat to children, smokers, and ex-smokers. This odorless gas is the second leading cause of lung cancer after smoking. A single installer can apply up to 300 square meters of passive purple a day using an airless spray device. This speeds up the construction time and cuts labor costs dramatically. It is M1 class, which is the emission classification of building materials. Materials that are M1 class are low emitting, so that material emissions do not increase the requirement for ventilation. VOC free. It is a water-based product. No nasty chemicals. Friendly for the user and environment. Volatile organic compounds, VOCs, are organic chemicals that have a high vapor pressure at ordinary room temperature. Some VOCs are dangerous to human health or cause harm to the environment. Many air tightness solutions contain harmful VOCs due to their ease of use in application, so a product that doesn't have any VOCs will have better outcomes for you, the installer, and the end user. Finally, this liquid applied membrane can guarantee you a score of 0.6 ACH, air changes per hour, and under, as tested by the Passivhaus Institute with an airtight score of 0.03 ACH. That's 20 times under the required 0.6 ACH needed. We'll now take a look at two examples of where liquid membranes have been used for air tightness. Case Study 1. Our first case study comes from an apartment block in Great Yarmouth. With people still inhabiting the building, the installers needed to overcome a multitude of challenges to achieve maximum results. This liquid applied membrane was used as an air tightness membrane, sprayed to the outer face of the original walls. Brackets were then fitted, which created a void for the eco-bead insulation. The walls were finished with magply board, a frame-tight weather membrane, battens and a Steny pre-finished render board with a textured finish. The flats were being improved from SAP EPC ratings of D and C. Case Study 2. Our next case study comes from a passive build based in Cambridge. Here you will see the results of when our liquid applied membrane brush is used to seal all Reflecting back to the start of this CPD and the learning outcomes that were set out, you should now have a clear understanding of the different solutions available for achieving airtightness, the latest regulations around airtightness, and the revolutionary benefits a liquid applied membrane can have. We hope you've enjoyed our CPD on advanced technology for airtightness, and we hope that this new knowledge will help you to achieve improved outcomes for you and your clients. If you'd like any more information on our new liquid applied membrane application, you can contact one of our experts using the details on screen now. Thank you for watching.